Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program today. And we are so quickly heading into the holiday season. And man, the time is flying by. We're going to have this show and I'm going to talk with Ralph after the program. And, fingers crossed we can get one more in maybe, middle of next week. And then, Computer America traditionally does take a break between Christmas and New Year and a little, a few days after that. So Computer America will be back probably around January 9th because the 8th is my birthday. I'm going to take that off. And then around the 9th, we'll be back then. And of course, then we'll be jumping right into CES coverage and all that good stuff. It's going to be a lot of fun. So just want to give everyone, start putting it out there that we're going to take a little bit of a break and then we'll be back early next year. So ladies and gentlemen, I hope that you have a great one. But more relevant to today, as I said before, we have Ralph Bond. He is our science and tech trends correspondent, joining us here in just a moment to talk all things tech, science, and ladies and gentlemen, we have a lot of great stories, and in fact, a birthday. And unfortunately, I don't have the birthday song queued up like Craig used to, but we have a birthday to talk about that, while not a person, is very, very, very influential to everything that we do, especially here on our program. So that's just story number one. We have a couple of different stories and they're always uplifting. So ladies and gentlemen, computeramerica.com, that is where you will find everything from the show notes, links, articles, if you want to get into more detail. Ralph does a great job of distilling the topics that we discuss, but if you want to find out more, we always make sure to make that very, very easy to do just by visiting my site, Ralph's site, and of course all the sites that we pull from. Now, also be sure to check out the site for reviews, contests, giveaways, social media links, podcasts, video archives, all that and more, computeramerica.com. That is enough rambling for me today. Let's go ahead and bring Ralph on and start having fun with today's program. So, science and tech trends correspondent and of course longtime contributor to Computer America, Ralph, welcome back onto the program. How you doing?
Hey, Ben, great to be back. And today, as you said, we'll start with a big electronics anniversary. Geeks like us have been celebrating all week, and it culminates with today. And also, just in advance here, folks, I'm fighting a big, nasty chest cold, so if I sound a little gravelly and nasal, that's why.
I think you sound great. So, yeah. And,
okay, thanks.
And of course, so before we start with story number one, why don't you go ahead and introduce, kind of what we do with our segment and yourself, to anyone who may be new to our segments.
Yeah, welcome new viewers and listeners. Here's the scoop about me. I'm an aggregator of science and tech news features for the show, and I find them by monitoring a host of online news outlets all day, every day. I love it. I look for important stories that don't usually capture mainstream press attention, and sometimes they're weird and quirky stories. I'm always on the lookout for news that gives a glimpse into where we're headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it. And what I do, along with Ben, of course, is present the essential points and in a digestible form. And I stress to our audience, as Ben did earlier, please come out to computeramerica.com. Get today's show notes. You'll have the links, pictures, everything, so you can dive deeper into each subject, because believe me, there's a lot more science, a lot more technology information in each of these articles than what we're going to give you today.
Absolutely. So yeah, and I think story number one is really going to show that off because I'll be honest, sometimes you link to one source, maybe two, and I think that for story number one, because it is such a the history is so rich that you have 1, 2, 3, 4, 5, 6, about 9 different sources for story number one. So, ladies and gentlemen, check out the show notes. And Ralph, I think we should start with the transistor.
Yes. And the mainstream press in this case has been covering this story, particularly National Public Radio. I give them a lot of credit here. But the headline is, Today marks the 75th anniversary of the first successful test of the transistor. And of course, as been made note of, I consulted a lot of sources, including my own family history, and we'll get to that in a moment. So on this day, December 16, 1947, scientists at Bell Labs conducted the first successful test of their semiconductor amplifier, and it's also a switch, the transistor. Now, over time, the transistor totally revolutionized the field of electronics and paved the way for all of the electronic devices in our lives today. That's how significant this is. And as one of the most important building blocks of modern electronics, many historians contend its invention stands as one of the most important scientific inventions in world history, right up there with the wheel and stuff like that, folks. Okay? But first, for those who may not be familiar in detail, what is a transistor? So in the most fundamental terms, a transistor is a semiconductor device used to amplify or switch electrical signals and power. And another definition is a transistor is a semiconductor device for amplifying, controlling, and generating electrical signals. And transistors are the active components today, in recent history too as well, of integrated circuits or microchips or chips, which often contain billions of these minuscule transistor devices etched into their shiny wafer surfaces. So again, we're jumping forward in time a little bit here. And in its role as a switch, the transistor either prevents or allows current to flow through. And that's important too when you get into things like binary logic and so on and so forth. Anyway, let's go back to Bell Labs. Let's go back 75 years ago. Here's what motivated the researchers at Bell Labs to create the transistor 75 years ago. And it took them quite a few years to pull it off. So an amazing team of scientists at Bell Labs, most notably John Bardeen and Walter Bratton, working under William Shockley, who was the team head, wanted to replace the unreliable and hot vacuum tubes as well as slow electromechanical relays that at that time were used in long-distance telephone service equipment with something. They wanted something that would be much more reliable and cost-effective. And Ben and many of our listeners are way too young to remember the era of tubes. Our first TVs in my family all had tubes. And one of my jobs as a kid was to go to the grocery store and buy replacement tubes, believe it or not. Anyway, so back to Bell.
And actually, the only story that I've really heard about tubes, and this I think came from Craig, was that really the idea of percussive maintenance really came into effect because sometimes the tubes would become unseated and you would have to hit them to kind of reseat the vacuum tubes, kind of back to where they were supposed to be. So sometimes hitting the TVs would actually fix them. So
yeah, sometimes. Fun that's where the tradition of smacking a device comes in. You're right. Absolutely. So
don't do that nowadays, though. Yes.
Yeah, that's true. So back to Bell Labs. So the ideal substitute the team created to replace vacuum tubes used to amplify, which, by the way, the vacuum tubes were used to amplify weak electrical signals and produce audible sounds. So what they created to replace these vacuum tubes was a highly reliable solid-state transistor, which offered dramatically smaller size and significantly less power consumption and heat output, right? And that was also important. Now, here's a qualifier. Although today we're celebrating the first successful test of the transistor, but the team also a week later or so demonstrated the discovery on December 23rd. And some people consider that the date the transistor was invented, which, I think is more important that today we celebrate the first successful test. That's really the key. And later on this 23rd, that's one thing. And then we're going to find out just coming up right now in terms of sharing news with the world officially. However, it was not until June 30, 1948, they waited that long at a press conference at Bell Labs. They publicly announced their invention. And I love this part here. This has to be one of the world's most unintended understatements of all time. At the event, a spokesman for the labs claimed, quote, "It may have far-reaching significance in electronics and electrical communication." Yeah, it may.
Yeah, and of course, looking back, I think it's fun to say, obviously it did, but that's a big trend in technology. There's tons and tons of instances where it's like, oh, the internet, it's a fad. TV's, nothing's gonna replace TV. Stuff like that happens all the time, but it's amazing that they were able to document it, the way that they did. So.
Yeah, exactly. And then more history here. 9 years later, Bardeen, Bratton, and Shockley received the Nobel Prize in Physics in 1956 for the first transistor. And the first commercial applications for transistors were hearing aids and pocket radios in the 1950s.
Nice.
And my grandfather gave me one in the very late 1950s, and you'll see why in a moment here. But that's kind of interesting. Hearing aids and pocket radios. Okay. And by the way, the pocket radio business and transistors is how Sony became this gigantic, massive, worldwide important company. But that's a whole other story. Now, Bell Labs didn't stop developing the transistor in 1947. They continued on. And fast forward to 1959, scientist Mohammed Attallah, who was from Egypt, interestingly enough, and Dawan Kang, I hope I'm pronouncing that right, a Korean person, at Bell Labs invented the metal oxide semiconductor field effect transistor, which is the most widely used type of transistor. And this was another major step in the advancement of transistor technology, which ultimately helped lay the foundation for the development of semiconductor chips. So another gigantic contribution from Bell Labs.
Yeah.
And then over time, of course, I think most of us know perhaps this history. Scientists like those at Fairchild Semiconductors and later Intel and others figured out how to super miniaturize transistors and perfect manufacturing of transistors and integrated circuits. And a little segue here for a moment about Fairchild Semiconductors in the Bay Area, beginning of Silicon Valley, right? So the folks at Fairchild Semiconductors, this was founded in 1957. By scientists who came to California first to work for William Shockley in Palo Alto, where Shockley grew up. That's why Shockley came back to California and why the Silicon Valley started. It's because in large part of William Shockley. But these folks left to start their own venture. So another little nugget here, a semiconductor chip, also called an integrated circuit, is an electric circuit with many components such as transistors and wiring formed on a semiconductor wafer. So fast forward to today, Ben, you and I, all of our listeners probably know this. The silicon chips in our smartphones, computers, TVs, cars, you name it, may contain millions, if not billions of microscopic transistors on a chip the size of a fingernail, more like the fingernail on your pinky finger, or smaller. And I love this part too. You talk about the advance of transistors in semiconductors and chips and all this good stuff. Recently, I think a week and a half ago, maybe, Intel announced that they predict there will be 1 trillion transistors on their chips by 2030. And that's 10 times the number of transistors currently available on modern central processing units, or quote unquote brain chips, like the ones that power your laptop or smartphone, etc. And here, finally, here's how the 75th anniversary of the transistor is a personal family history interest to me. And I'm so proud of this. I just love this. My maternal grandfather, a French fella, Gustave Charles de Coudelet, there's a mouthful for you, was on the team. He was on the team at Bell Labs working with William Shockley and Bardeen and Bratton. And he was a French scientist who was recruited by the U.S. Army during the First World War to help develop our military's radio technology. So our government became aware of him, became aware of his availability because he was very sick from fighting in the First World War. He was in hospital, and our government said, "Can we have this guy? We need help." And fortunately, France said, "Sure." And he met and married, comes to the United States, meets and marries my maternal grandmother, became an American citizen, and contributed to the field of electronics for decades. In fact, about a 30-year career at Bell Labs alone. Now, regarding William Shockley, after work, my grandfather and Shockley would sometimes go up into the attic of my grandfather's home in Madison, New Jersey, and do research and experiments. Now, for people who know who William Shockley is, I want to make a very clear statement about this. Unfortunately, Shockley was an ardent eugenicist whose theories of black racial inferiority eventually made him an academic pariah. He was a difficult person, a tough personality, and had these wackadoodle ideas, sad to say. But to my knowledge, my grandfather did not share his beliefs, and I know for a fact from my mother's stories that my grandmother did not like Shockley at all.
Yeah.
So anyway, but more on a happy note to end this little segment. I'll never forget the day in the late 1950s. I think maybe I was 6 or 7 years old when he was visiting us in California. He was so excited to give me a transistor pocket radio. Oh my goodness. I was old enough to be thrilled to get this amazing gadget, but too young to understand its significance. So there's how it ties into my family. And this day is a big one for me and my family. So there you go.
Yeah, no. And of course, being able to add the personal flair to the story, I think adds a lot. And thank you so much for sharing that. It's, and to be able to look back and say that I knew that guy. I was there at the founding of the technology. Not too long ago, we interviewed the gentleman who created the first cell phone. We've interviewed the guy who created the mouse.
Wow.
We interviewed the guy that created, some of the display technology behind, modern monitors and things like that.
Sure.
I mean, that's the kind of fun thing about technology. Going back to the basis of medicine, of architecture, going back to the basis of art, of so many sciences. Ralph, there's not many other fields that you can think back and go, oh yeah, my father worked with that guy, my grandfather worked with that guy.
Yes.
I met him in my lifetime. Technology is so nascent, it's so young, but it's so fast evolving, and I really do feel like the transistor is one of the best showcases of that you showed off here. Lots of work and technology and breakthroughs in the 40s and 50s, and here we are 70 years later with Intel promising a trillion of these little guys
insane.
On a single chip. It's incredible how fast it's going, but of course, like you were saying, it wasn't that long ago, but it's a huge step forward. So very, very glad that that a lot of news publications have been updating this and following this. This was an amazing story, and I'm glad that we got to share that with our audience.
Yeah.
Yep. So, story number one. And again, want to reiterate, if you wanted to find out more about that, because I'm sure, Ralph had to, go through, dozens and dozens of events and just pick out, cherry pick his favorite ones.
Yes.
If you want to find out more, there's 10 different sources in the show notes. Go ahead and check that out. Now, story number one. Story number two. Let's go ahead and get back to a more traditional story that we, more traditional fare that we have here on our programs. Story number two has to do with hydrogen fuel cells, which are luckily, they're a little bit different than traditional batteries and lithium-ion batteries and things like that. It's a concurrent technology that has a lot of promise for green tech, green energy, and renewables. So story number two, this is a good one.
Yeah, it is. And just a qualifier before I give the headline, this is not going to be the first time we've talked about aviation's, the aircraft industry's interest in hydrogen fuel cell engines as a replacement. But what's, I think, significant here, Ben, is a monster giant in the field, Airbus, putting their endorsement, if you will, on this. So Airbus, here's the headline. Airbus plans to test a hydrogen fuel cell engine on a modified super jumbo jet. I got this from futurism.com, a wonderful outlet. So earlier this month, aviation giant Airbus announced plans to test an experimental hydrogen fuel cell engine on a modified A380 super jumbo jet. Now, their goal is to see if it's possible to power a large commercial passenger airliner with hydrogen alone. And that goes back to some earlier stories we've done this past year that's coming to a close, where we talked about hybrid things. Maybe it's a hydrogen combined with traditional fuels, and, all these different ideas are fully electric with batteries. But they're thinking about hydrogen alone with this test, okay? And for the audience that might not be fully familiar, a little bit, why hydrogen? Why? Well, hydrogen is a clean fuel that, when consumed in a fuel cell, produces only water as exhaust and some heat as well, too. In addition, this is interesting, too, and this goes back to something a couple of weeks ago we talked about. In addition, an aircraft engine powered by hydrogen fuel cells produces zero contrails, which today account for roughly 2% of global warming. You maybe recall a few weeks back we talked about some technology efforts to modify contrails so that they would not do the heat, global warming problem. So here they're saying, well, gosh, if we had these engines on our aircraft and the whole world's aircraft industry converted, we could knock out 2% of global warming right there. So that's interesting. Now, Airbus, is planning to start test flights in 2026 of its new Zero E, that's zero all caps with a lowercase e, fuel cell engine, which it unveiled at the company's summit earlier this month. And here's how the Zero E fuel cell engine works, and this is very simplified. It uses fuel cells to convert hydrogen into electricity to power its super high performance propeller engine. And this is so interesting. If you look at the picture that's in the show notes, you see the kind of ovoid-like shape you expect to see in a jet engine, but instead of the traditional format, there's actually exposed to the air propellers at the back end. And so it's kind of going back to the old propeller concept in terms of exposed propeller. So anyway, Airbus says... Excuse me. Sorry, folks. Airbus says its goal is to launch a fully operational zero emissions passenger aircraft by 2035. So this is a long range effort here. Now, the obvious bottom line here is moving to hydrogen would dramatically cut the carbon footprint of air travel, which has historically been responsible for 2.8% of global CO2 emissions. And remember that, 2% of that is from contrails alone. So this could make a tremendous shift if the entire world's aircraft industry shifted over, which is perhaps a little overambitious, but at least it's a step forward. And again, as I stress, having Airbus put their certification of approval on this it's significant.
Yeah. Airbus is definitely a huge name to have behind this, because they're the ones that operate those planes that go from point A to B and B to A over and over and over and over again. Very routine, very set amount of miles and speed and distance and travel, all that kind of thing. Ralph, what I kind of like about this is that the airplanes on fossil fuels, you have to go out, get the fuel, that kind of thing. With hydrogen, right. I guess the big part about that is that you can create that with natural and with green energy. You can create that with solar and wind and that kind of thing. It's not the dream of a solar powered airplane, but it's the next best thing. And the fact that with hydrogen fuel cells, anyone who's kind of seen the buses that are running on this now, Ralph, you can just swap essentially the batteries, the fuel cells. You can just swap them out and let them recharge and refuel them and then swap them back in. It's for a plane, it makes all the sense in the world, because as far as refueling goes, it would be probably even quicker than gasoline to get these planes fueled back up and ready to take its next flight. Buses, planes, all that kind of thing. Perfect technology, and I'm glad that they are going to be testing this. It's a really natural fit.
I think it's very encouraging, and let's watch over the next 10 years or so here and keep your fingers crossed.
And once they do get it off the ground, if I can say that, wait. Okay, if they get it off the ground, Thank you. They will really have an economic advantage over a lot of their competitors, and of course, that would then drive the entire industry to move to this as fast as they can. So, great story number 2, and I like the tie-in with the previous story about the contrails. That one was a real eye opener and continues to be, honestly.
Yes.
So, ladies and gentlemen, go back and check out that episode. Story number 2, story number 3, and now we're heading into medical technology.
Yes.
And we always like it when we have new solutions to eternal problems. And story number 3 is really showing that technology can hopefully cure the uncurable. So, Ralph.
Yeah. And you know what? We forgot to mention that the mission of our show each Friday is to leave you feeling better about the world, right? And this one really fits the bill, and it really is. Often I like to end with medical breakthrough stories, and this is a good one. So here's the headline: Radical new therapy for Parkinson's will use stem cell transplants. And this I got from the UK's Guardian News Service, which is a wonderful outlet. So here's the story. Recently, researchers at Cambridge University announced a groundbreaking new treatment for Parkinson's disease that uses nerve cells derived, or I should say created, from lab-grown stem cells. So we're going to step through this here and explain why this is so important. First, though, Parkinson's disease is triggered when nerve cells in the brain that supply dopamine to the brain start to die due to a combination of genetic and environmental factors. Dopamine helps a person control movement. So when supplies drop in the brain, the result is shaking, stiffness, depression, and other debilitating symptoms. It's a horrible disease. But here's the good news in 2 parts. First, the Cambridge team figured out how to grow stem cells in their lab, and we'll speak to that more in a moment. And second, with help from scientists at Lund University in Sweden, they were able to transform these stem cells into dopamine-producing nerve cells. Ding, ding, ding. Mm-hmm. Starting next month, the first experimental transplants of these lab-created dopamine-producing nerve cells will be used to replace those destroyed by Parkinson's disease in the brains of test patients in the first clinical trial. And being able to create dopamine-producing nerve cells is wonderful, of course, but growing stem cells in a lab is also a big deal. So a little refresher here. Remember, stem cells are the body's raw materials. They are the cells from which all other cells with specialized functions are generated. So being able to grow stem cells in a laboratory, in laboratory cultures is very important, as it provides an alternative to the controversial practice of using stem cells from, for example, human embryos or fetuses. Aborted fetuses, that is, of course. The Cambridge research team stresses, however, that it will take 5 or more years before we know if this new approach will become a standard treatment for Parkinson's disease. But hats off to Cambridge and the Lund University team for giving great hope to Parkinson's disease folks. Yeah. And my wife said, "Oh yeah, doesn't Michael J. Fox, the actor, have that disease?" And I said, "Yeah, I think he does." And oh my gosh, it's if you know somebody with Parkinson's, you know that if they can figure this out, if they can transplant these dopamine producing nerve cells created in the lab into these patients and help give them some relief, God bless them. That'd be so great Christmas gift, if you want to put it that way.
Yeah, there are a lot of diseases that once you kind of get the diagnosis, you just try to manage and delay and stall because there are no options otherwise. But with this breakthrough and others, there was another story this week as well where a 13-year-old girl with leukemia was cured due to CRISPR, which we've talked about on the program before.
Yes, right.
She's 6 months cancer free, and little breakthroughs like that kind of build up over time really go to show that, hey, I know that we're all we're all doing the 5Ks, we're all donating, every year, we're all putting money at it, but to finally see some results, and I say finally, knowing that there's been, progress year over year, but it's good to see, Ralph, that, so much effort and resources and research are leading to actual results. So
Yeah.
it's story number 3 really goes to show that. And while, traditionally we have 4 stories, so I didn't want to leave everyone hanging. And Ralph, I wanted to maybe just spend a minute or two talking about story number 4. We're not really going to, I'll include the source where we're talking about it in the show notes, but just want to say that there was a big breakthrough. And as far as technology goes, hey, this is right up our alley. Where this happened this happened in the United States at the National Ignition Facility in California. And U.S. scientists got to announce that they finally achieved a breakthrough in nuclear fusion. And we talked about fusion here on the program. There are, places in China working on it. There's, of course, the EU that's working on it with, Ralph, I want to say the Large Hadron Collider, but that's not about fusion. But, there are organizations all over the world. Really pouring in resources. And this one, Ralph, just to put a little, just put a dollar amount on it, this facility was a $3.5 billion experiment to see if they could make this work. And the breakthrough for everyone who's been living under a rock was that they were able to achieve fusion, but for the first time, they actually monitored more energy escaping the reaction than what they put in. So they were able to put in 2.8 megajoules, and they were able to get out 2.05 megajoules, and they were able to produce 3.15 megajoules of energy output. So, Ralph, that's a fairly big step. And I'm wondering, kind of what coverage you had seen about this over the week.
Well, what I saw was a lot of excitement. It's a great breakthrough of everything you said. Yeah. But there were also people that said, and you and I were discussing this before we went on air today, I think everybody needs to put it into proper perspective. This is just the beginning. Fabulous, exciting, important. But at the end of the day, how many more years will it take for them to get this process to be mass producible, mass deployable, safe, and so forth, and practical and cost effective? That remains to be seen. Probably not in my lifetime, would be my guess. But then again, technology can accelerate so fast once you get going. But the promise is amazing. I understand, what was it? More than 100 super high power lasers were focused in on this material to cause this reaction. And by the way, folks, one of the simplest ways to understand what fusion's all about, and the press has made this very clear as a topic or help to explain, it's what's going on in the sun. Yeah. What they're doing is replicating the process that gives us the incredible energy and light from the sun. And it is bizarre to think about more energy resulting than going in to create the process. That's just mind-boggling. But if we can achieve this, it will change the whole world. But we need to be patient, and we need to put it into proper perspective.
So to and just so everyone, because I didn't really hear the nature of the actual experiment, and I wanted to outline that they're able to put a tiny amount of hydrogen into a capsule the size of a peppercorn. So you can think of a peppercorn, very, very tiny. Yes. At the center of, if you're watching the video portion, you can kind of see this room. These are 2 scientists inside of this chamber where they have 192 lasers.
There it is,
at this peppercorn, and they're able to heat this thing with the 192 lasers. And by the way, Ralph, again, this is all big numbers, so I'm trying to put this into perspective. 1 megajoule is a 1-ton car traveling or impacting something at 100 kilometers, which is like that's like 80 miles an hour or something like that. 80 miles an hour like hitting something. So you can imagine that much force created by lasers, all focusing on these on these group of hydrogen atoms. Smash them together. They create helium, which is obviously, if you're looking at the periodic table, 1 to 2, creates helium, and all the extra little bits, all the extra neutrons fly off, and that's the energy that's released. So, and that's where you kind of get that extra energy, and that's the point. That's the best part, is that you're able to release more energy. And of course, hydrogen is the ultimate renewable energy. That is the most prevalent element in our universe. So as soon as we figure this out, there's no more, kind of hoping that we get enough sunlight,
Right.
There's
Right.
enough fossil fuel, Ralph. It really is the idea of infinite energy and infinite clean energy as well. It's
Would be
it's the Holy
exciting.
Grail. But with
It
your
is.
skepticism,
It is.
with your skepticism, very well placed, because even the scientists behind it, Ralph, I know that you said it just like everyone else said before this experiment. We're still 50 plus years from anything like this being achievable. But at least now he gave a new timeline of a few decades, which could put it anywhere from 30 to 40 years. So this is a huge step forward. But in terms of, everyone's going to have one of these in their basements, and they have to go, kind of shovel more hydrogen into their fusion reactor every winter. We're not there yet, but it's a huge step in the right direction. And man, the implications of, Ralph, just imagining everyone, everywhere, and everything being powered, no matter kind of what you do, is just so perspective changing. I don't even know.
Oh my gosh. Yeah.
So with an extension cord, you can do anything. So there you go. That was an unofficial story number 4. But all these stories are, of course, great. Everything from the anniversary of the transistor to more eco-friendly airplanes, cures for previously uncurable diseases.
Yes.
Ralph, I think you really hit it out of the park today.
Well, thanks, Ben. It's been great.
Absolutely. So, ladies and gentlemen, if you want to hear more Ralph, we of course have an entire section dedicated on our YouTube channel, all things Ralph. Our stories are very research heavy, so even stories months or years later are still very relevant. So don't be shy about going back and checking past episodes. Also, he is of course a tech reporter for the Mark Mason Show over at KEX Portland. If you are local, you can check him out there. And Ralph, thank you so much for joining us here. We're going to talk hereafter to see when our next segment is, but it's been a lot of fun. So, ladies and gentlemen, until next time, have a great day. Thank you so much. Bye, everyone.